I'm here with William Garnier, Head of Outreach and Education for SKAO. Can you tell us a bit about how SKAO works with industry and what are really the reasons you need so many companies to work with you?
Yeah, thanks, Adriana. Well, look, that's an interesting question, and there's multiple answers to that, right? I mean, first, starting from the beginning, the SK Observatory, SKAO, is an international organization, an intergovernmental organization. So we are funded by many countries around the world. In our case, what makes us quite unique is that we've got members across the 5 continents. So that's the first thing. And then, obviously, when a country becomes involved in this, in this endeavor, it's for the long run, right? So they're in it for the next 50 years or so. And so, obviously, the primary driver for countries to be involved is the science. We are poised to deliver transformational science. So once the telescopes, we are building 2 telescopes, one in Australia, one in South Africa. Once the telescopes are operational, then we will be delivering world-class science, and hopefully there will be some Nobel Prizes, out of the discoveries that will be made with our telescopes. So that's your main driver for countries to join, to get access time to the telescope for their science community. But it's not the full story, because what governments are interested in is job creation, innovation, um, skills development, and all the rest of it. So a big part of the equation is what we call the industrial return on investment. And so you want to demonstrate to the countries getting involved in the observatory that they will get some contracts back, for their industry to be involved. And so that means, as I said, like creating jobs. Obviously, it's money, back into the country, and it's also an opportunity to enhance, if you like skills development and technological development and so on. And so that's exactly what's happening here. I mean, with the UK being, one of our key partners, hosting the headquarters of the observatory. And so the way it works, then we need some expertise, among UK, universities, but also UK industry to be able to industrialize, some of the design which has been done. And then you look at where, the best experts are, on the market, because we need industry to make these very, sometimes very niche, if you like, high precision instruments or technological developments to meet our needs and to enable, the great science that we will be doing with the telescopes.
From our perspective, we started conversations about part of the future SKA project over a decade ago, and it took roughly 8 years to deliver a compressor for Meerkat Plus. So we do understand that from our business perspective, from our engineering perspective, that meeting this scientific, very precision-driven instrument is a very difficult task. So for us, it's a very good challenge as a company, because we see the impact we can make. Because science is growing. So we would also like to understand, where are we going with SKA? Because it's a massive investment, it's a massive array. So why do we need it so big?
So you're right in saying that, as far as your involvement is concerned, it dates back 10 years ago. The SK project itself was born over 30 years ago as a concept. And so at the time, it was in the late 80s, early 1990s. And so, scientists, they always want to answer the next big questions, and to try to understand more, about our universe. And so in that case, at the time, one of the biggest unknowns was to try to understand the formation of the first stars and galaxies. And at the time, they made some calculation. And in order to detect that very weak signal coming from the dawn of the universe, which has traveled more than 13 billion years to get to us now. It's really extremely weak. So you need very, very exceptional conditions. So first you need to put your telescope away from our own interference, away from electromagnetic interference, away from civilization, basically. So that's why you've got very few places on Earth which meet that particular requirement. And at the same time, you don't want to be too isolated either, because you need to you need to have access to these places. You need to build infrastructure. You need to bring all of your components and your high technology and so on. So it's a compromise between these parameters, right? So that's the first thing. And then when they did the calculations, they realized that in order to do that, in order to detect those very first and weak signals from neutral hydrogen, which at the very early stages of the universe, you need 1 square kilometer of collecting area, hence the name Square Kilometre Array. So now obviously once once you are developing a telescope of that scale and of that size, then you realize that you can actually do much more than the primary purpose. So that's why the science case of the SKA has evolved and has grown and has expanded dramatically over the last 30 years. Because again, once you've got the technology to do that one thing, that detection of the neutral hydrogen from the early universe, you can do many, many, many other things. And so the science case has evolved, and then the technology, has evolved as well, obviously. So it's this mix of, science, science case and technological developments. And then you need to, to glue all of this together, and you need the governance structure in place as well, to be able to build and operate this sort of facility. And all of this takes a lot of time, right? So that's why, going back, to the recent history, the last 15, let's say 13 years have been absolutely critical, because there were many years of what we call detailed design. So it was basically engineers from around the world for each of the systems and subsystems of the telescopes, getting together, refining the design and using either like emerging technologies or developing new technologies in order to meet the scientific requirements. And all of this has taken a lot of time, and it's groups of engineers from around the world, including industry, public institutions, universities, etc. And so at the time you mentioned your involvement, you were involved with one of the precursor facilities of the SKA telescope, the SKA-Mid telescope in this case in South Africa, so Meerkat, and developing some of the technologies for the Meerkat telescope. And now Meerkat is expanding into what we call Meerkat Plus. So it's this facility in South Africa where we are actually building the SKA-Mid telescope as well. And now Oxford Cryosystem is involved in developing the cryogenic system for the SKA-Mid dishes as well. And so it's, as you say, it's a long journey, which would take some time. But the technology that you guys are developing is absolutely critical for us, right? I mean, we need to consider that we are in very harsh environments. It can be very hot out there, in the Karoo, which is a semi-desertic area in South Africa, and some of the frequencies that we will be observing with the receivers, they require to operate at very extremely low temperatures, right? And the reason being that you want to avoid, heat creates movement of particles basically. And as I said earlier, what we want is to try to remove, any noise, because the signals we are trying to detect are extremely weak. So any noise, any movement of particle, we want to try to avoid, in this case. And so that means cooling it down to like very close to absolute zero in this case is great because it allows us to get like a signal which is more pure, if you like. And that's exactly what we need, in order then to be able to, digitize that signal and then to, to send it to the processing facilities and all the rest of it. So that's where we are. Now we are building the telescopes in Australia and South Africa. We've got most of the infrastructure on the ground already for the SK dishes. We've got a few SK dishes on the ground already, and we are now starting to install, these receivers. So each receiver will be able to detect some frequency range. And then we need all of the technology to enable that and to enable us to start doing science very soon in the next few years.
We are really excited about this journey, as you said, because we learned lessons from the Meerkat, and then we learned lessons from the Meerkat Plus, and now they're coming together for the SKA-Mid. So we take the best outcomes from those test projects and those developments, and we hope that that will be even better in the future. And you mentioned the particle movement and the low noise amplifiers being critical, but also to keep that in the context, we need close to absolute zero temperatures in the middle of a desert. And we have to use a compressor that also generates heat, generates airflow. So for us, it's an amazing challenge and very difficult challenge because you need that helium compressor hanging off the antenna of the Meerkat and on the SKA-Mid. And this was a very difficult engineering project. So we're excited about it, and we're very proud that we managed to make it work to such a high spec that you guys can use this.
Yeah, I mean, I think none of us would be here if it was easy, right? We love our challenges, uh, and that's what you need in order to deliver the great and transformational science that we promise the community that we will be delivering in the next few years. So you really need this cutting edge technology in many different respects. So what you're describing here, in terms of cooling it down to close to absolute zero in the middle of very hot sometimes environment is one of these challenges, and again doing it so without generating more interference or by limiting as much as possible the interference that you generate is indeed a key challenge, which has never been done before in that scale. So it's something quite unique and unprecedented, which is why sometimes, and that's part of how science works, right, and how R&D actually works. You need to test your limits. You need to go out there to do some developments and to get it wrong, right? And it's only by getting it wrong that you will learn your lesson and understand what's not working, what needs to be improved, what new system, new technology, needs to be developed, and then you improve your system, and it's an iterated process, which never stops. And that's why we are talking about cutting edge technology, and that's why we are working with companies around the world, including yourselves, which are really in line with that, and which are really like reaching the limits of what we can do as far as technological developments are concerned.
Yes, for us, it's a challenge, as I said, but also it's a great honor to work in a project that puts so many businesses and so many academic institutions together, so many governmental organizations together. Because if you look at, our compressor, it's massive compared to the person, but on the antenna, it's somewhere very tiny. And that antenna is just one of so many antennas. And that puts you in a perspective that in order to observe the universe that's immense, we do need massive array that we all together have to build.
Yeah. What I think is fascinating as well is obviously from you've got different ways of looking at these big science projects, right? And so many people out there, members of the public, what they will see and what they are, interested in is like the sort of science which is delivered by these facilities, whether it's astronomy in our case, or particle physics, with CERN, and or nuclear fusion, with the ITER facility as well, there's but when you look, there's one aspect which is common to all of these, these facilities, is the multinational nature as well. Because what it means is that you are bringing expertise from different parts of the world. Everybody is contributing to it in their own way. And I was mentioning earlier these like groups of engineers working together for refining the design of the telescopes and the subsystems. And in those groups, those consortia, as we used to call them, it was the entire world right there, right? You had like 10, 15, 20 countries sometimes involved, and getting together with everything that comes with it, in terms of cultural differences as well, and cultural challenges, and understanding each other, understanding where the other is coming from and what they are bringing to the party, and learning from that, and comparing points of views, and that's a great reflection of human nature and how society actually works, and we make it work in our own ecosystem, if you like. We make the world work together under the same umbrella and with the same mission, which is advancing our understanding of the universe, advancing our understanding of science and science processes and stuff. And that's why the science diplomacy aspect of our organization shouldn't be underestimated, because that's, again, it's bringing people, cultures, countries together with the same objective, which is one of the things I find the most fascinating actually in my job.
Because I do enjoy those international conglomerates of people. So when we look at our publications, for instance, our customers are publishing from 78 countries. And we're hoping that with SKAO coming to full power when scientists start using it, we will see people from more and more countries using equipment that we deliver to science. Because science is multinational, and we want to bring that scientific equipment to as many people as we can.
Absolutely.
Thank you very much, William. It's a pleasure to speak with you, and thank you so much for having us here at Jodrell Bank.
Thank you. It was great. Thank you very much.